streaming. I want to hide OBS. Honestly, we can hide everything and then pull this up. Okay. Can I just close that out? Yeah, that's what I want. Okay. Then, let me see. So I think with us, we need to do section 1.2, and I should have a blank of that already. Let me go ahead and load it. Let me just hide the chat. I think it's like this. Let's go back. So we're going to do 1.2 together. I think this is us right here. It should be a blank version. Yeah. Let's go to edit. Let's duplicate this. Yeah, this. Come on. All right. Shoot. Okay, week 2, 1.2. This is college algebra. We meet Tuesday, Thursday. Oh, okay, that would have been nice. That's okay. 2:25 p.m. 2:25 p.m. Fall 2020, and we can get rid of all of this. Okay. All right. College algebra. This looks good. Done. And let me add a page. Come on, quick. View as a single page, and you come down here. And I think that looks good. Okay. So let me see. Let's hop over here. And where's our Zoom? Nope. How did I get that to work last time? Maybe it was full screen mode, and then I did like this. Speaker view. Let's see if I hop over here now. Okay, that's what I wanted. And I want to do one more thing. So I have this here, and then the chat window. I'm going to monitor that as well. Okay. Okay. So now a few housekeeping rules. Keep in mind that I am streaming this live to my YouTube channel, right? So if you're subscribed to my YouTube channel with your notifications turned on, you should have gotten a notification. And I mean, honestly, attendance, do the best you can with attendance. We're here. Just be here, really. That's the simple thing. But so my intent is to stream each session, so that way we're streaming live via YouTube, right? So as soon as class is done, I'm basically streaming my desktop, so what I see. So then as soon as the lecture is done each time, that'll automatically be a copy loaded to my YouTube channel, right? And honestly, like, we kind of go through different things with my different classes. So you guys, your rhythm is a little bit different than my other classes, right? So we only meet twice a week. So I'm not going to be as detailed with you all as I am with my others. So you can always kind of like listen in on the other conversations. You can watch those videos as well, take notes. So like the classes right after you, they've already kind of worked through this section that we're about to do now. So there's actually a presentation already on YouTube for this one, but we're going to do the best we can to take our time today. So since we don't have a lot of time together, we have maybe like 40 minutes, something like that. As you have questions, I am monitoring the live chat, so you can actually type your questions there, or just write them down, and I'll periodically pause to answer questions. So otherwise, just kind of write it down and save it to the end. Okay. I want to say Pearson should be loaded with everything for the semester. Outside of exams, the first exam isn't scheduled to hit until week 4, and I just need to check Pearson to confirm that this is properly set up. But otherwise, honestly, as long as your assignments are in Pearson proper, that's all I really need. And if you need help, again, with Pearson, you want to use the question help, make use of the Ask My Instructor, track down the tutors. Keep in mind, we've already paid for tutors. They're included in your tuition. So Morehouse has tutors available, right? So take advantage of them. Also, I haven't gotten an update on the Pearson code, but last correspondence that I got, last piece of information I've gotten was that out of the bookstore, you should have a choice of either getting a book or getting a MyMathLab access code. So you got to reach out to the bookstore and get that from there. Okay. I do have a workaround to keep it free. It's kind of bulky, but again, if the bookstore has those access codes ready to go, then that's ideal. If the bookstore doesn't have the access code ready to go, I have a free workaround. Honestly, the free workaround is when your trial expires, just make a new account with a different email, but use the same name, and I can actually access all of your scores from all of your accounts. The best thing is to have one account that has all your scores, but I can pull them from all the different locations. Okay, so we have a way to keep it free. You know, it's just something I discovered on my journey. So it's kind of been working for a few years now. But again, if this is included in your tuition, the best thing is just get the full access from the bookstore. That's the best practice. Again, if we have questions, write them down, and we'll take some time towards the end of class to kind of address questions. Okay. So, and let's move this over to try to get just a little bit of space. That's a little bit better. Okay. So, I think last time we did section 1.1. So today we want to do the best we can to make it through section 1.2 with lines. These are the objectives. I'm going to let you read through these on your own just for the sake of time. So we're going to introduce this section with some terminology. And we can open up with, let me see. So we have, since the graphs of first degree equations and two variables are straight lines, these equations are called linear equations, right? So a linear equation, the highest exponent of any variable is going to be 1, and it's going to basically make a straight line. And we say the steepness of a line is called the slope of the line, okay? Again, if you have questions as I'm going, just write them down or type them in the chat, and I'll address them as they arise. I am monitoring the chat. So we can continue this discussion of slope. What do we mean by slope? And so the rise is going to be the change in the y-coordinate between points, and the run is going to be the change in the x-coordinate between points. Okay. Notice with this graph on the left, if we have the first point and the second point, as we trace it left to right, it goes up, right? It's going up. With the second graph, as we go from the point on the left to the point on the right, as we trace it left to right, it goes down, right? So this first one over here to the left is an example of a line that has a positive slope, and this is an example of a line that has negative slope, okay? And again, a slope being positive or negative is based on us tracing it from the left to the right. This is my left. I kind of want to see if I can change those settings. I'm not going to make a big deal about that now. Let me see one thing real quick. Caesar salad. And that, oh, that's, okay, so I'm just kind of playing around with the mirror, right? Because even though it's showing that word spelled correctly, I think the image is mirrored because this is actually my left over here, right? But on the screen, it looks like my right. So that's interesting. That's neither here nor there. I'm just kind of playing around with stuff there. Okay, let's keep moving because I know our time is precious. You guys can't see my screen? Okay. Yeah, because if you didn't say nothing, that's going to continue. Okay. So let's go here, share like this, and actually the whole desktop, share. Thank you for the update. Okay, so that looks good. We're gonna go like this and put the chat back. Come on, maybe it was like this. Nope, that's not it. Go here, there's that. What if I click here and then do that?
Chat there, right?
Oh, I know you can see it. I'm trying to pull up my chat window. There it is. Okay. Yeah, thanks for the update. Again, I am monitoring the live chat. Okay. Okay, cool beans. There was something else I wanted to check. Let me go here to settings. Share, meeting, no, breakout rooms. Computer sound. Okay, I'm not going to worry about that. Okay, and I'm going to go ahead and lock out this session because sometimes my students in the next class, I'm going to enable a waiting room, and I'm actually going to lock this out so that way we don't have people from the next class trying to get in. Okay. Okay, thanks for the update. All right, moving along. So yeah, otherwise what was going to happen is you'd have to watch my YouTube video to see what I'm seeing. Okay, anyway. So then we have the slope of the line, right? So slope is nothing but rise over run, which is the change in y over change in x. And this is going to be our y2 minus y1 over x2 minus x1. Many professors force you to memorize formulas like this. What I'm going to do for my class, all I really need you to do is like maybe have a formula sheet. Have one sheet of paper, maybe at the end of your homework notebook, where you every time you come across a formula, just add it to your list of formulas. We don't. I'm not going to force you to remember it, but you definitely need to know how to use these formulas, right? So again, slope formula is change in y over change in x. So that's going to be a rise over a run, y2 minus y1 over x2 minus x1. Okay, and the slope of a vertical line is undefined. Okay, so this example asks us to sketch the graph of the line that passes through these points, and then find and interpret the slope of the line. So if we're going to sketch the line, all we would do in order to sketch a line, we just need two distinct points. So we have the 2 points. We would just plot these points and draw a straight, connect the 2 points with a straight edge, and then the slope will be the rise over the run. I'm actually going to calculate the slope now instead of counting it. We could count it from the graph, but I'm just going to calculate it. Also, one of my mentors would say every time you use a formula, write it down. So the slope is going to be y2 minus y1 over x2 minus x1, right? And what I personally do whenever I have a set of ordered pairs, I go x1, y1, x2, y2, right? So then if we apply the concept, y2 is 3, y1 is negative 1, x2 is 3, and y1 is 1. Okay. Double negative is positive, so 3 plus 1 is 4. 3 minus 1 is 2, so then ultimately the slope is 2. So what we're saying is, let's go like this, style, we want the fill, come on, to be none. And we want this actually to be a little bit thicker, kind of like that. So with the slope being 2, we're saying that the rise is 2 and the run is 1. So we're going to go up 2 and right 1 in order to get to a second point, right? So we see here we have our points are plotted. The first point was 1, negative 1. And then the second point was 3, 3. If we count the rise versus the run, we went right by 2 and then up by 4. So then the rise over the run was 4 over 2, and that's where the slope of 2 came from. Okay. Okay, so I don't see any questions in the chat, so I'm actually going to keep moving forward. It says the slope of a line through these 2 points. Okay, so we actually crunched this already. So we saw a demo on this formula. So we're going to keep it moving. Okay, we're going to let that be as well. Main facts about slopes of line. As we trace a line from the left to the right, lines with positive slope rise and lines with negative slope fall. So if we trace it left to right and it goes up, that means it has a positive slope. If we trace the graph left to right and it goes down, it has a negative slope. The greater the absolute value of the slope, the more steep the line is. Vertical lines are undefined. The slope of a vertical line is undefined, and the slope of a horizontal line is 0. Quick question. I think we've mentioned this, but I just want to mention it again. Again, the champion doesn't have to be told what to do, only reminded. If we have 0 divided by some number, what is this equal to? Versus if we have some number divided by 0, what is that one?
Well, if zero is being divided by a number, that means that number is being multiplied by 0. However, the same can't be said for the number being divided by 0, because 0 can't go into any other number than itself.
Okay, that's essentially it, right? So 0 divided by some number, this is okay. This is okay, so this is going to be equal to 0. But some number divided by 0, that's a KO. You want to knock that out. So that's going to be undefined, right? So 0 divided by some number, that's okay. That's going to be equal to 0. That's okay. But some number divided by 0, that's a KO. You want to knock that out. So that's going to be undefined, okay? This actually comes in, I mean, I like to mention this at this point because I know that sometimes students get tripped up by this notion. So either I had a student show me this or a YouTube video, but I came across it. I was like, oh, that's a great way to remember it. So 0 divided by some number k is going to be okay, so that's equal to 0. But k divided by some 0, that's a KO. You want to knock that out, so that's undefined. Okay, let me see something. Yeah, we're good. Okay. So it says if a line has a slope m and passes through a point, then the point slope form of the line is going to be given by this. So we use this formula again whenever we have a point and a slope. I might do one demo showcase in this form. It is a good idea to add this to our formula sheet, but I'm a fan of just using the slope intercept being y equals mx plus b, right? So this one says, actually, I think I'm gonna just do this one in slope intercept. It says find the point slope form of the equation of the line through this point with the slope, and then solve for y. All right. Can somebody tell me the slope intercept form of the equation of the line? Y equals. So yeah, this is y equals mx plus b. This is called the slope intercept form, right? This is the slope intercept form, right? So I'm actually going to do this one using this form. So I'm going to let I'm going to let 1 be my x, negative 2 is going to be my y, and we see here the slope is 3. So if we plug those into the slope intercept form, let me see, y is negative 2 equals, the slope is 3, our x is 1, and b is the only thing we don't know, so we need to solve for b. Right? So then we subtract, ultimately we get b equals, I think that's a negative 5. So now if we plug in our slope and our b, y equals 3x minus 5. Okay. So now we can confirm as many of the details about this solution as possible. Let's see. So first let's verify that it passes through the point 1 comma negative 2. So what this says is when x is 1, y should be negative 2. So if we plug a 1 in, 3 times 1 is 3. 3 minus 5 is indeed negative 2, and that checks out, right? So that checks out. And then notice also that the slope is 3, so we're good to go there as well. Okay. So that's about the best we can do, checking something of this nature. I'm watching the clock. We're moving and grooving. It's going to be over in the blink of an eye. Okay, so don't blink. Don't hold your breath. We need to breathe. I need all my students breathing. I've actually lost students from Morehouse, sadly enough, and it didn't dawn on me until I got to graduation. Like I remember one commencement, I had a student. You know, he was a student. Nothing. I don't want to say he wasn't special, but he was just a student, just a normal person. And then I heard something in the news, and it didn't register who that student was, and I just thought it was sad. And then I get to graduation, and they had like an empty chair for him with his image. I was like, oh, that's who that was, and that's when it dawned on me that was my student. That was, I think it may have been like a hit and run. It was something just a tragic. It was either a hit and run or maybe some kind of gun something or another. But yeah, like no day is promised, right? So just live your life. You know what I mean? Like we're not guaranteed anything. So do your best, forget the rest, don't stress, and be blessed. So we have a type version where they apply the point slope form, right? So where we let 1 be our x, they let 1 be their x1, and negative 2 is their y1. It's the same thing. It's just a point, right? So we have this point and we have this slope, and you see how we can plug those into the point slope formula. And then after you do all the algebra, it eventually boils down to the same answer that we got. 3x minus 5, okay? We got the same result. So we saw two different ways of doing the same thing, okay? All right. Let me get some water. I kind of want to give you a chance to do this one, but because our time is so precious, I'm going to just kind of keep moving. You know, I personally feel like time is more valuable than money, right? Like money comes and goes. We lose money, we can go make more money. But like this moment in time, we don't ever get this moment in time back, right? Today is August 27th, 2020 at 2:50. We don't ever get this time back. So like it's a peeve of mine when people like waste your time. And when I realize that they're doing it intentionally, I was like, oh, they're trying to waste my time. And like I kind of want to be upset, but I'm like, no, they're just doing their job. It's no reason to get upset. Just decide if you want to play the game. If you don't want to play the game, just send them into some other abyss, right? You don't even have to engage. When you argue with a fool, you can't tell who's who, you know. So that's just when people are intentionally wasting your time. But yeah, I definitely encourage people to live their life. Now, what we're invoking here in the collegiate atmosphere, I want to say it's like seeing the forest for the trees. I never can use that quote right, but we're like doing delayed gratification, where we're still gonna live our life, but we're doing our work on the front end. The assignments are due Saturday every week, Saturday by midnight. So I think I made last week and this week. So 1-1 and 1-2 are both due this Saturday at midnight. But honestly, you can work on my assignments past the deadline with only a 10% late penalty. The only thing is be careful about putting off your assignments because they will pile up fast, and before you know it, you're gonna be like, wait, it's a lot of work, right? But yeah. So anyway, find a point slope form of the equation, the line passing through these points, and then solve for y. Okay, I'm just gonna kind of work this one my own kind of way. So again, I'm a fan of the slope-intercept form, which is our y equals mx plus b. Again, I had students show it to me in the past. I confirmed it. It actually works. So I like it, so I use it. But now, in order to use the slope-intercept form, again, I think the question wants us to use point-slope form, which is y minus y1 equals m times x minus x1. And we could use that, but I'm actually going to use the second one. And before I use the second one, I need to find my slope. So slope is going to be y2 minus y1 over x2 minus x1. So these are the three main equations that I use when I'm working with lines. So whenever I'm working with lines, I have these three equations ready to go. Okay. I think the question wants us to start with the first one, but I'm going to use the second one. But in order to start with the second one, I need to find my slope. So let's go ahead and label these x1, y1, x2, y2. And the main thing about the slope formula is that we need to be consistent. We don't really have to do the second point first. We can do the first point first. We just need to be consistent. So let me show you what I mean by that. If I do y1 first, I would say 1 minus 7 divided by, but now the 2 definitely needs to come first. So negative 2 minus 3. Right? So I did y1 minus y2 over x1 minus x2, as long as I'm consistent. Okay. On top, we're going to get negative 6 over a negative 5, so it becomes a positive 6 over 5. Okay, so that's the slope. That's our slope. So then once we have the slope, hey Google, give me a random number 1 to 2.
Here's a random number, 1.
Okay, so I'm just going to choose the first point, right? We could have chosen the first one or the second one. So now if I take that first point, it's going to be, again, we're using y equals mx plus b. So if I'm choosing the first point, my y is going to be 1. My slope is going to be 6 by 5. My x is going to be negative 2. And b is what we need to solve for. We don't know b. Okay, ultimately we get that b equals, that's a negative 12 by 5. So 5, let me see, if we're going to add, we're going to have 5 by 5 plus 12 by 5. Again, you can use calculators. I'm just practicing my ability to do this by hand. And we get 17 by 5. Okay. Solve for y. So then we should have, the equation should be y equals 6 by 5x plus 17 by 5. Okay. So then we can check this as best we can. For instance, when x is negative 2, y should be 1. I'm just going to use the notes. I could show it in the calculator if needed, but I'm just going to use the notes for the sake of time. 6 by 5, x plus 17 by 5. I think we got the same thing. And I think they use the point slope, so that's another reason why I'm intentionally doing the slope-intercept, so we can have two different versions of the same thing and show that we can arrive to the same conclusion. Oh, we're missing something there. The line that passes through, I'm going to just leave this as an exercise. I'm going to leave this one as an exercise. So we've discussed the slope-intercept form already. Graph the line whose equation is given by this. So if we were going to graph this line is already in the form of y equals mx plus b. It's already in slope-intercept form. So from here, this is easy to graph. The y-intercept is going to be 2, as you see in the red circle. That's our y-intercept. So we would go to y-axis and put a point on 2. And the slope tells us how to get to the second distinct point. So a rise of 2 and a run of 3 means we go up 2 and right by 3, and we put a second point, and then we connect those 2 points with a straight edge. See here, we started at the y-intercept of 2, and then if we go up 2, 1, 2, and right by 3, 1, 2, 3, we get this result. We plot the second point and connect it with the straight edge. Okay. Again, if you have questions, either just write them down and save them to the end, or type them into the chat, and I am monitoring the chat. Okay, we're actually almost done with this section, and then we can kind of close out for the day. For any constant k, the graph of the equation y equals k is going to be a horizontal line. So whenever we have y equals some number, that's going to be a horizontal line passing through the y-intercept of whatever that number is. And then x equals a number is going to be a vertical line through the x-intercept of whatever that x value is, right? So for instance, in this example, if we have y equals 2, that's going to be, that means no matter what x we choose, y is always 2. So you could actually make a few set of points, right? Just choose a few x's. You could say let x be -2, y is going to be 2. Let x be 0, y is going to be 2. Let x be 1, y is, no matter what x we choose, in this case, y is 2. You plot those points, we get a horizontal line through y equals 2. It's a similar discussion for x equals 4. No matter what y value you choose, like y is -3, x is always 4. Say y is, I don't know, -1, y is 4. Say y is 5. No matter what y value we choose, the corresponding x, in this case for part B, is going to always be 4. So if we plot those order pairs, we'll have a vertical line through x equals 4. All right, so here's the first one, right? No matter what x we choose, y was always 2. So we had a horizontal line through y equals 2. And then for the x value, no matter what y value we choose, we had a vertical line through x equals 4. Okay, so if we have a question, write it down. Give me no more than, we're not going to go more than 10 minutes at this rhythm. Okay, then we'll definitely call it today. Either 10 minutes or us getting to the end of the slides, whichever comes first. So then we have the general form of the equation of a line. It's going to be this ax plus by plus c equal to 0, where a, b, and c are constants, and they're not both a and b are 0. This is how we're going to define a line. This is called the general form of the equation of a line. Okay. Find the slope, y-intercept, and x-intercepts of the line with this given equation. Okay. So let me start by getting a copy of the original. 3x minus 4y plus 12 equals 0, right? If we want the slope, y-intercept, and x-intercept, my first mind says let's go ahead and solve for y. All right, let's just go ahead and solve for y. So if I want to get the y by itself, I'm going to do the inverse operation here. So the opposite of subtraction is addition. So I'm going to add 4y to both sides. And then we're going to be left with 3x plus 12, right? Because we're dividing by a monomial in this case, we're going to divide both sides by 4. Because we're dividing by one term, we can actually separate the 4 in this way. Divided by 4 and divided by 4. Again, because we're dividing by one term, we can split it in this fashion. Otherwise, it just needs to be entire right-hand side divided by 4. Then what we're left with is y equals 3 by 4x plus 3. Okay? So then kind of, let me see. So now it's clear that the slope should be 3 by 4. For the y-intercept, we're going to set x equal to 0. If we set x to 0, I think we get an answer of 3. So the y-intercept is 0, 3. And the x-intercept, what we would do is set y equal to 0. Okay, we can choose any of these equations. If we set y to 0 and solve, I'm going to choose the original. We're going to have 3x minus 4 times 0 plus 12 equals 0. Notice that this is gone. Subtract. X is going to be equal to negative 12 by 3, which is negative 4. So the x-intercept should be negative 4 comma 0. Okay, so we got the slope, x-intercept, and y-intercept. Give me just a moment. We're almost done. We're either almost out of time and we're almost done. Style. Again, if you have a question, either write it down or type it into the chat. Almost there. So we got 3/4, 0, 3, and negative 4, 0. And I think we see all the results there. Okay, I'll do this one. So it says the height h of a human male is related to the length of length x of his femur by this formula. Well, all measurements are in centimeters. The femur of Wild Bill Longley was measured to be between 45 and 46 centimeters. Estimate the height of Wild Bill. So if his femur is between 45 and 46, let's plug in when x is 45. So when we have 45 centimeters, then his height could be 2.6 times that 45 plus 65, the result. And then when x is 46, we do the same thing. The height's going to be 2.6, again this is a 2 here, 2.6 times 46 plus 65. Okay, so, and then we would crunch those numbers and we would get a result. Let's just do it really quickly. Hey Google, what's 2.6 times 45 plus 65?
The answer is 182.
Okay, let's see how we do it. That will be centimeters. Hey Google, what's 2.6 times 46 plus 65?
The answer is 184.6.
Okay. And then let me just do a quick demo on how to convert from centimeters to, like, let's do feet, right? So say we have 182 centimeters over 1. Centimeters, let me see, 2.54 centimeters corresponds to 1 inch. And I'm going to say times. There are 12 inches in a foot. Okay. Notice, because I had centimeters on top, when I do my conversion, centimeters need to be on bottom. Because I had inches on top, when I do my conversion, inches need to be on bottom. So now these units cancel, we're left with the desired units. It's going to be feet. So basically it would be the 182 divided by those, the product of those two results. Okay, so let's just kind of go to the next slide. So we have a typed up version of all that we just did. 182 and 184.6 centimeters. And then they converted it to, I think those are inches, and then they went from inches to, he's about 6 feet tall. Okay, it's an approximation. We say that two lines are parallel if they have the same slope, and perpendicular means they have one slope times the second slope is going to be equal to -1. Parallel lines have the same slope but different y-intercepts, so they run side by side and they never touch. Perpendicular lines cross and make a 90-degree angle. Bukonotsuju. And then you got the shadow clone jutsu or whatever. But he does something kind of like this and think in Naruto. But anyway, he makes a 90-degree angle. Yeah, so these zoom directly to my YouTube channel, so you could actually go there. It should be streaming and picking up properly. So hopefully everything is working properly. Okay. Any two vertical lines are parallel, and any horizontal line is perpendicular to any vertical line. I think I'm going to leave the rest of this as an exercise for you all to do. Okay. Give me a moment. I'm going to go ahead and load a copy of these notes into our box link, and then we can entertain questions, comments, and concerns. So give me just a moment. Let's hop back this way and put this back like this. Can we, how do we full screen mode? I'm going to stop sharing because I'm done there. And I'm going to go like this. Okay, that looks better. It is what it is. I'm not going to stress about that. Let me share. Send this to box. The location. This is 2024. There. This is the 225. Into the notes. Yeah, so we just finished out section 1.2, right? So on Pearson, once that bar finishes loading, you can actually get a copy of all the stuff that you saw me writing. On Pearson, we have our work on Pearson. This week should just be 1-1 and 1-2, and I think I loaded as many assignments for the entire semester as possible, just shy of the exams. I think that to be the case. Okay. Would anybody like to ask any questions about anything from today? Okay, guys. Maybe send each other chats, like send each other cell phone numbers privately, because this is streaming to YouTube. Okay, guys. You don't want, like, I'm gonna go ahead and close out that chat. It's no worries. Does anybody, if there aren't any questions, so you're gonna have your work cut out. Luckily, we have a recording, so you can always go back, pause, slow down, rewind. You have to seek out the tutors. You have to make use of the Ask My Instructor. I'm glad that you guys are. It's definitely a good idea for every class that you're in. Have the contact of at least 2 or 3 different of your classmates for every class that you're in. Can't think of anything else. You guys want to ask any questions? Go ahead, Mr. Thomas.
So
wait a minute.
I ordered a book, but it hasn't come in. Well, I didn't order it. I ordered a book voucher, but it hasn't come in yet, and they said that my voucher is still being processed. What do I do for like the
Pearson?
code when I run out?
Well, yeah. So there's a couple of things. I mean, when is it scheduled to expire?
Well, that was next week.
Yeah. So just let it try to kind of hold out, and try to get your hands on that access code. All right.
Okay.
And then even if it expires, we have a workaround for that. Okay.
Cool.
All right. Any other questions from anybody?
I do.
It's Nkosi, is that right?
Correct.
Go ahead.
How do we access the previous Zoom recordings again?
It's on my YouTube channel. On the syllabus, Beautiful Mind Pfeiffer. I think I streamed Tuesday session. So today is Thursday. So I did stream on Tuesday. And the first day was just like introduction. So I had a meeting that day I couldn't get out of.
Gotcha.
Okay. Other questions? Okay, guys. All right. If there aren't any other questions, I'm gonna let everyone go. Just kind of keep working through the material on Pearson. Maybe for section 1.3, try to read ahead. So like maybe if you have a copy of the book, or if you can access an ebook, or you can actually go through the PowerPoint lecture slides as they are on our Blackboard in the note section. So just try to get ahead, so that way when we meet on Tuesday, hopefully that lecture can be a review. I think on Tuesday, I think we'll just do the first half. It should just be, next week should all just be section 1.3. Right? I think we're devoting all of next week to just 1.3. Okay? All right, guys. Otherwise, have a good weekend, and I'll see you on Tuesday. Take care.
Thank you.